This is a current divider which is comprised of two resistors in parallel. And the way to calculate the current through each resistor is by using Ohm's law. So to find the current, you divide the voltage by the resistance. So to find the current through R1, it's just the voltage, V, divided by the value of R1. And to find the current through R2, it's the voltage divided by the value of R2. And let's give those some values. So R1 is 1K, R2 is 470, and the voltage is 5 volts. So using those values, so 5 divided by 1000. So the current through R1 is 5 milliamps. And the current through R2 is using the formula voltage divided by R2 is 10.6 milliamps. So the way to calculate the equivalent resistance of the two resistors is the reciprocal of R1 plus the reciprocal of R2, and the sum of those two reciprocated. And the way to do that on a calculator is this. So 1000 reciprocated, which is just 1 over 1000, plus 470 reciprocated, and now reciprocate that answer, and there's the collective resistance. So 320 ohms would be the equivalent resistance of the two resistors. So here is the actual circuit, and there's no power applied presently or no voltage across the circuit, so I'm going to measure the collective resistance. And there's the collective resistance. Now it's a little off, and that's probably due to the tolerance of the resistors, so let me just check that real quick. So this is a 470 ohm resistor, and it's measuring 460, so that would explain part of it. And now let me just measure the 1K. Yeah, so the 1K is low as well, so that explains why the calculation was slightly off. Alright, now I'm going to apply power to the circuit. Change that to voltage. So there's 5 volts across the two resistors. Now I'm going to measure the current through R1. Change to current. And this should measure, yep, 5 milliamps. Now I'm going to measure the current through R2, which should be roughly 10.6 milliamps. Yep, really close to 10.6. So there you go.